This presentation is about solving literal equations. You can see from this first example that a literal equation is an equation that consists of several variables, and we're just trying to solve for one of them. We're trying to solve, in this example, for t. So we want t by itself, and currently we have p by itself. So right up here, p equals IRT. I want this to say t equals something, and again, I'm going to solve it in terms of variables. So if I begin over here, p equals IRT, I know that I want to isolate t, so I ask myself, what is happening to t? What's happening? It's being multiplied by I and r. What's the inverse operation? The inverse operation of multiplying by I and r is dividing by I and r. So now I have p divided by IR equals t. When I input that in, it will look like this. T equals p divided by IR. Because division happens first, I put this in parentheses so that I know that I have p divided by both I and r. Both I and r are going to be in the denominator. I do not have to write t equals because it's already up here. So t equals p, and it needs to be a capital because it's a capital in our equation, divided by IR. That's the way that I would enter it, like if I was answering it in Schoology. That's the way that I would enter it. Here's our second example. Again, you can see there's several letters. We're just solving for one of them. So we can see up here that we're solving for b. Here's b. We want to isolate it. So what is happening to b? Well, it's being divided by 3, and it's being added to a and to c. So based on SADMEP, which is PEMDAS backwards, order of operations backwards, we're going to do subtraction and addition first. Well, we have some addition, don't we? But this line indicates that all of this is being divided by 3. All of it. A plus B plus C is all being divided by 3. Because it's all being divided by 3, it's an implied parentheses. And parentheses actually happen last. So we're not going to do our addition and subtraction yet. We're going to keep going through SADMEP. Okay, I have division and multiplication. Am I dividing or multiplying by anything? Yes, I'm dividing by 3. What's the inverse operation of dividing by 3? Multiplying by 3. So if I rewrite my equation, A equals A plus B plus C divided by 3. To undo division by 3, the inverse operation is multiplying by 3. So now I have 3A equals A plus B plus C divided by 3 multiplied by 3. 3 divided by 3 is 1. That's an identity. So these no longer exist because of the identity property of multiplying by 1. So 3A equals A plus B plus C. The parentheses are gone now because we've gotten rid of the division, and I can use the inverse operation of subtracting A and subtracting C. So I have minus A minus C. 3A equals, not ready for equals yet, 3A minus A minus C equals B. So when I enter that, I have B equals, which is already up here in text, and I will write 3A minus A, these are different A's, capital A and lowercase a are different, minus C. So you see they're in alphabetical order. The capital number is first with the coefficient. When I type it in up here, it looks like this. 3A minus A minus C. We'll move on to our next example. Here we have t minus yc equals b. So again, several letters. We're going to use inverse operations to get the letter we want by itself. So the letter we're trying to isolate now is C. So here's C. What is happening to C? Well, c is being multiplied by y by negative y, and it's being added to t. So if we're going to use SADMEP to do our inverse operations, what are we starting with? We're starting with addition or subtraction. So I'm adding t, I'm going to go ahead and use the inverse operation and subtract it. So I have t minus yc equals b. I'm subtracting t from both sides, and I get 0, which is an identity when adding or subtracting, so it's gone. Negative yc equals b minus t. So I've done my addition and subtraction. Following SADMEP, now I'm looking at division or multiplication. I'm multiplying by negative y, so I divide by negative y. And I have c equals b minus t divided by negative y. And I just rearrange it using commutative and associative properties and distributive property to simplify this. I don't want this negative in the denominator because it creates a double sign. So I commute that to the front, and I have c equals negative b minus t divided by a positive y. Now I can distribute the negative. So c equals negative b plus t, so negative b plus t divided by y. And I put this in parentheses so that I know that I'm adding before I divide. Order of operations tell me I have to divide first, so I want to make sure I throw that into parentheses. Negative b plus t are lowercase, divided by y is lowercase. That's the way that I would enter it into Schoology. In our next example, we're solving for h, and they tell us here, because we're typing this in, we're going, rather than using the pi symbol, which is difficult to do in Schoology, we're going to use pi in parentheses. You want to make sure you put the parentheses around it so that it functions with the code. So what's happening to h? What is happening to h? Here's h right here. What's happening to it? It's being multiplied by pi and r squared. What's the inverse operation? Dividing by pi and r squared. So we have h equals v divided by pi r squared. When I type that in, h equals v divided by parentheses pi r squared. And again, I have the parentheses around the denominator telling us that these are both being multiplied together. Don't divide v divided by pi first. Multiply pi times r squared, and then do the division of v divided by pi r squared. The parentheses help with the order of operations when we type it in. So v, and again it's a capital V, divided by pi, in parentheses, r, shift 6 gives us our squared symbol, squared, our caret symbol, and we close our parentheses. That's the way that you would input that into Schoology. Example 5. We're solving for y. What's happening to y? It's being multiplied by negative 10, and it's being subtracted from 50. I begin my inverse operations. I add 50. This is an identity, 0. When you add or subtract 0, it's an identity, so it's gone. And I have negative 10y equals 6x plus 50. I divide by negative 10. And again, I'm dividing each term by negative 10. Negative 10 divided by negative 10 is an identity. That's 1. When you multiply by 1, it's an identity, so that is just y. I have 6x divided by negative 10. And I have 50 divided by negative 10 is negative 5. And then I can reduce this. So y is equal to 2 goes into 6 3 times. 2 goes into 10 5 times, negative 5, minus 5. And I'm going to commute my negative to the numerator again so I don't get double signs. I have negative 3x divided by 5 minus 5. I don't have to do parentheses here because order of operations tells me to divide. before I subtract. So when I type that in, I already have the y equals minus 3x, lowercase x, divided by 5, minus 5. Next example, f. What's happening to f? Well, it's being multiplied by 5, divided by 9, and subtracted from 32. So multiplied by 5, divided by 9, and subtracted. 32 is being subtracted from it. So when I do these inverse operations, on the other side, I have c equal to 5/9 times f minus 32. The negative 32 is in parentheses, so I cannot do that first in our SAD map, even though it's subtraction. Because it's in parentheses, it's at the end of our SAD map. So I begin by dividing by 5 and multiplying by 9. You'll notice this is a reciprocal. So when I multiply by 9 and divide by 5, I'm multiplying by the reciprocal. 9 divided by 9 is 1, that's an identity. 5 divided by 5 is 1, that's an identity. When we multiply by 1, we get the same thing. So it's an identity. We have 9/5 c equals f minus 32, and we can just add 32. 9/5 c plus 32 equals f. I wrote that as a 5, equals f. And I'll go ahead and type this in up here. 9c divided by 5 plus 32. Why did I put the c in the numerator? Well, this is being multiplied, so I've got 9 times c over 5. Here we're solving for v. What is happening to v? Well, here's v, and it's being multiplied by t and subtracted. 16t squared is being subtracted from it. So we're going to go ahead and do our SAD map. We will add 16t squared to both sides. And after we've done that, we have h plus 16t squared equals vt, and we just divide by t. So we have h over t plus 16t squared over t equals v. And again, we see here that we can reduce that. So we have h over t plus 16t squared, which is t times t, divided by t. T divided by t is an identity, that's 1. So now we just have h divided by t plus 16t equals v. And that's what I'll go ahead and type in. I've got h divided by t. I do not need parentheses because division comes before addition, times 16t. So order of operations tells me divide before you add, multiply before you add. I don't need parentheses here. And that is my simplified term. Example 8. Solve for w. What's happening to w? Well, w is being added to L. It is being multiplied by 3. And it's being divided by 2. Because these are in parentheses, that's what this long line tells us, add before you divide, I'm going to have to undo the multiplication by 2 first. So I'll multiply by 2 on both sides to begin. And I have 2r, capital R, equals L plus 3w. Now I can use SAD map because the parentheses are gone. I can go ahead and do my addition and subtraction. Minus L, so 2r minus L equals 3w, and then I can divide by 3. Again, this implies that this is in parentheses, so when I type it in, 2r minus L divided by 3, order of operations tells me to do L minus 3 first, or L divided by 3 first. I don't want to do that, so I'm going to put in parentheses to tell me that that is in the numerator.